is now we're going to engineering. So let's welcome IBK.
All right. Good afternoon, everyone. My name is Ibukunoluwa Ajayi-Banji. I'm a doctoral student at the Department of Ag and Biosystems Engineering here at NDSU. And today I'm going to be giving a presentation on my research for the past 2 years on the green and semi-green soybean color and quality changes during drying in the laboratory and in-field and under different storage conditions. So to the problem statement, in the Midwest region, focusing on North Dakota, as an example, where we sometimes experience early frost on soybeans when temperatures fall below 0 degrees Celsius. What we see in this picture here is, the ice formation on the soybean ports. And when, we have this condition on soybeans, when we have this frost condition on soybeans, and it happens at the R6 maturity growth stage, where we have the green seeds filled with pods, what happens is that at the time of harvest, we have an issue with the quality of the seeds in terms of the color and the composition. Also, at the R7 stage, from a lot of research that has been done, minimal impact on the quality of the seed is actually observed at this R7 stage at the time of harvest. However, at R8, it's been recorded that little to no changes might be experienced if a frost happens at this condition. Now, okay, right. So when this actually happens, what we see here, the picture here is just showing the color. If you take a close look at this picture, you can see some green tones, some green beans, with some of them semi-green in color, and a dissection of the picture of the beans you have here. You can see the inner discoloration with that green color to the beans. And when farmers harvest their beans and then they proceed to actually sell these beans, what happens is that they are heavily discounted at the elevator because of the green tone that they actually have to their beans. Also, the oil from these beans, you can see this green tone to the color. The cost of refining the oil is very high for processors because of the presence of chlorophyll that is actually present in the oil. So to be able to address this challenge, there's been a lot of preliminary studies that has been done saying that green beans and semi-green beans will actually change color in storage. But really there hasn't really been like any real research, in the laboratory to actually ascertain, these claims. So for the first phase of our research, what we actually did was to evaluate the impact of drying and storage conditions on the color and quality of green and semi-green soybeans at 2 different moisture contents and at 2 temperatures over a period of 6 months. So based on the outcome that we actually had from the phase 1 of this research, we proceeded to actually go to the phase 2, where we evaluated the effect of field drying and storage conditions on the color and quality of green and semi-green soybeans at the R6 and R7 stage at these conditions over 6 months. So to our materials and methods, what we did was we harvested soybeans, at the R6 stage, that's when we have green seeds, and we can see the green pods at this point. And then we proceeded to harvest at the R7 stage. At the R7 stage, we can see the R7 pods. We can see some semi-green or yellowing that we can actually see to the pods. And then we proceeded to actually dry this in the laboratory using the cabinet dryer at this temperature over this period of drying for 48 hours. After the drying was done, what we did was actually we shelled with a thresher, and then we actually conditioned the seeds to 2 different moisture content of 12 and 17%. However, for the R8, which is the mature soybeans, we harvested at the harvest moisture content of about 12%, so we didn't have to go through that process of drying down. Now, what we did was to actually fabricate storage boxes with 4 different kinds of conditions inside. The first box that we actually had, you can see the presence of this fluorescent bulb. The reason why we had fluorescent bulb lights was just to mimic what we actually encounter on the field, when you leave soybeans to actually dry on the field and under proper exposure to sunlight. So what we did was we selected this bulb in the first box. The second box condition here, as you can see, we can see the presence of fan. We had this mini axial fan that was actually aerating air through the beans in the box. And then for the third condition, we had a mixture of both light and fan. And then for the fourth box condition, we had no light, and then we actually had no fan. That's no light and no aeration. And then we can see, this is the 4 box conditions I talked about. And then we actually now put these boxes under 2 different storage environments of 4 and 20.5 degrees Celsius. That's at cold and at room temperature. So for the first phase of our research, what we found out, so before drying, for the R6 spores that I actually showed earlier, these are actually the seeds from the pods before drying. And we can see the green tone that we actually have, so the seeds as expected. And then after drying, what we can see here, we can see that we have, we can see some fading away to the green tone of these beans. And we can also see like we have some, this yellowish color, this yellowish tone to it. So this was actually backed up with the Hunter color A value. So what we did was to be able to track the changes in this color that we're seeing, we actually used the colorimeter that measures color values in LAB to be able to track the changes. And it's been, from research, it's been observed that for grain samples, for example, this R6 here, you can use the A value to actually track how intense, how the intensity of greenness to a sample is, and also how it fades away. So here we can see that the A value is about minus 8.89. And then after drying, what we have is about minus 3.83, just showing the impact that we actually observed on the drying. So what we did next was to proceed to look at the effect of storage conditions on the color of this R6, R7, and R8 seeds. The R8 is actually the mature, which actually serves as our control. So from our generalized linear model, we had a two-way interaction of maturity stage, lighting, and storage period that was significant at a p-value of 0.05. So what we found out, what this graph is just, this plot here, this box plot is just showing us, is showing us the R6 green beans under light conditions. And if we take a look, we can see that over the 24 weeks of storage, we can see the increase in the color A values, tracking the changes that we're seeing under light conditions. The same thing is observed for the R7 seeds, that's the semi-grain seeds. Over the 24 weeks of storage, we can see the increase in color A values. However, when we look closely at the green seeds that were stored under no light conditions and the semi-green seeds at R7 at no light conditions, we can see that we have this compact plot, just tracking and just showing us that we have minimal increase in the color change under these conditions. And of course, the interesting thing is that this is actually the control, the R8. And here we can see that even for the control, we still actually observed some increase in color A values, showing the fading away that we actually had. So what we were able to conclude from here is that storage time and the presence of light in the storage boxes gave the highest color A values for both R6 and R7 soybeans, respectively. Okay, and then the graph I have here is just to emphasize what we observed under light conditions for samples that were stored under light conditions. So without light conditions here, we can see that R6, which is this like orange bar, we can see at the end of 24 weeks, we still have color A values that were actually not even close to that of the initial control at R8. The same thing for the R7. However, when we take a look at this with light conditions, we can see that about the 8th week, we're beginning to see the R6 having A values that is actually close to that of the control. The same thing for the R7. There have been a number of literatures that have actually reported that when you keep green soybeans, if the farmers keep their green beans inside their storage bins, after a period of like 6 to 8 weeks, they're actually going to see changes. So that's part of what we're actually trying to validate with this experiment. And then just to further show you what we observed. So this is the R6 green bean at week 0, and under light conditions at the end of week 24, we can see that there's some fading away to the color that we can see compared to what it was initially at the time, at week 0, at the time of storage. Also, it was important for us to also track the chlorophyll content changes that we actually observed, because we know that the deep green tone that we had to the seed was significant present, that we had chlorophyll presence in it. And from what we actually have here, we can see that what we did actually was to extract the oil from the R6 green soybeans before storage, and we can see this green tone color to it. However, for samples that were stored under light, after 24 weeks of storage, we can see that the color of the oil has actually faded and is actually close to that of the R8 control. That's the mature soybeans. Also, if we take a look at this graph, we can see the decline that we actually have for R6 after 24 weeks of storage. We can see the decline in the chlorophyll content, the same thing for the R7. And of course, the R8 was pretty much the same thing after 24 weeks of storage. So from the first phase of our research, what we concluded was that laboratory drying and light conditions in storage actually contributed, to the color of the R6 and R6 and R7 seeds significantly. However, we know that it's impractical for farmers here in North Dakota to actually have light in their beans. So what we did for the second phase of the research was for us to look at the effect of field drying on desiccated soybeans at the R6 and R7 soybean maturity stage. And we also went on to look at the effect of weather conditions during field drying on the desiccated soybeans. So for the second phase of the research, what we did was at Carrington Research Extension Center, we had 2 plots planted. The first plot was planted earlier in May, and the second plot was planted in June. So for the first plot that was planted in May, we desiccated the soybean plants at the R6 growth stage. However, for the plot 2, it was desiccated at a later time. So what we wanted to do was to compare the outcome of this desiccated R6 and R7 at the time of harvest and see if there were any changes that we could actually observe. So after the desiccation, the seeds were harvested. After the desiccation, the seeds were harvested and then dried down, conditioned to moisture content. And then we had them stored in these heavy-duty plastic airtight bags. And then we proceeded to store them in storage pails at these 2 temperatures. So this was the first thing that we found out. So for the R6 soybeans from plot 1 that was planted earlier, we observed that at the time of harvest, after desiccation, we had this was the color of the beans. And we can actually see this kind of mature, we can see that mature brown, golden yellow color that we expect to see in fully matured soybeans. However, for the plot 2, what we observed was at the time of harvest, we had temperatures that were close to about 2 degrees Celsius. At the time, we had very low temperature conditions. We actually had a frost occur prior to harvest, and then we also had rain. And then we went for that to just kind of based on what we're seeing visually, we went for that to look at the color A value, the color values. And what we observed is that for B value here, this actually gave us a better indication of the yellowness that we had to the seed at 18.12. However, for this one at R6, we had at 15.32. But one very interesting thing that we found out was the effect of harvesting condition on the chlorophyll content of the soybean seeds. What we actually expected was that for the samples that were dried on the field, I'm just going to pull that up quickly. For the samples that were actually, so this is for harvested without field drying. So this was actually from the first year of our research. When we did not desiccate, we just harvested at R6 and R7 and then brought in our seeds into the lab. So with the oil extracted from here, you can see the R6, you can see the deep green tone to the oil. The same for the R7, which was expected. And then for the control, we have this golden yellow color. However, when we actually compared that with our phase 2 research, what we observed was that for the R6 and R7 desiccated, despite the fact that we harvested under conditions that were not favorable, where we had the frost and all that, we observed that we didn't have that green tone to the oil, even though the color of the seeds we had was not that of the fully matured color because of the weather conditions. So we had R6 desiccated, R7, and then this is the R8 control, which also at the time was harvested frozen. So that was the interesting thing that we found out, that at the end of the phase of the research, field drying conditions we know definitely will be able to help farmers to be able to, possibly in times of early frost, they can actually leave their soybeans longer on the field for it to dry out. So field drying influenced the appearance and chlorophyll levels of the harvested soybeans. Also, we found that chlorophyll content was minimal. Chlorophyll content of the R6 and R7 seeds was minimal after field drying. And also in storage, we observed that minimal changes were actually observed in the color values of stored seeds after desiccation.